All right, it looks like we are online. We're going to do our customary check as we get ready for our live coverage. So let's make sure everything is working properly. And there we go. We're on YouTube. We're on the live chat. That looks like it's on. And we're on X. And of course, we're on, let's see, X, Facebook, and YouTube. There you go. So we are at that time of year again where, oh, let's face it, the audience drops off because we're not talking about winter storms anymore or rumors of winter storms or 15-day GFS guidance. And, those of you who are here, you're the hardcore fan base. So, again, I appreciate you being here because it actually means a lot to me. Your questions actually get answered faster because, you're the only ones here. So, that's certainly some good news. Tonight, we're going to talk about the spring weather pattern, what I'm seeing, what the forcing mechanisms are. We'll go over some of the ideas floating around there, especially with the polar vortex weakening and the state of the polar vortex evolving. What does that mean, and where we're going from there, and basically get some ideas of basically the warm season here. Okay, so part of this, of course, is just to kind of I don't like to be critical of other meteorologists, but there are some people out there who try to find a historic weather pattern in every weather pattern. Um, and really, it's a dangerous path to go because those weather patterns that produce, let's say, snow in April and whatnot, were historic for a reason because they're really, really rare and they're really hard to pull off. That's why they're historic because they're rare, right? So it's dangerous to make comparisons to significant years of winter storm potential or spring storm potential, depending on how you look at it. It's dangerous to do that with severe weather, like severe thunderstorms, tornadoes, and winter weather, because you're kind of pushing the worst case scenario with limited data. So it's kind of dangerous to pull that off. So let's take a look at the actual data here, and that's what we're going to focus on tonight. And away we go. So first we start off with our La Nina. Now, as you know, I've had some issues with the CPC naming this a true La Nina because the ONI is barely going to reach a month of verification on this. And typically you need 5 3-month periods. You might not even get the 3-month period set up here to support a La Nina event. So yeah, there were some La Nina conditions in Nino 3.4 for about 2 weeks. It has fallen apart. You could literally see the whole time period of this La Nina in this one graphic, telling you just how short-lived this was, which tells me that, hey, look, we're dealing with very weak tropical signals here. So our La Nina, if you want to call it that, is weakening, and it's weakening because the MJO is basically stuck in a El Nino-like signal in phases 7, 8, and 1. And it looks like it's going to be repeating that for a bit of time. So you can see the collapse here. And so the reason why I wanted to start off with this first is that, well, it clearly shows that we're not going to be dealing with a La Nina spring, but we're also not dealing with an El Nino spring. It's basically a neutral signal here in terms of ENSO itself. And in terms of the subsurface here, I wanted to show this is really important. One of the things I like to study here is, well, what's brewing below, right? What's brewing down here? And this is 300 meters below the sea surface down to 450 meters. And then you can kind of get the range in your temperatures here. And the reason why this is like right around the equatorial temperature anomaly. So this is basically your ENSO regions right here, right? So what this tells me is that, first of all, your cold support is fading steadily, rapidly. but you're also not seeing any El Nino signal. Now, when you're looking for an El Nino signal, yes, you look for warm water here, sure, but you also look for growing cold water here. And I'm not really seeing that. It's basically stable and unchanged. And the reason why you look for that is that, remember, El Nino or La Nina is not just about the sea surface temperature. It's all about the pressure gradient and the wind gradient. So the thermal gradient adjusts the pressure gradient. The pressure gradient changes your trade winds. Your trade winds impact your subtropical jet stream. Your subtropical jet stream then creates havoc for your forecast over North America. So it all starts with the thermal gradient and transfers over to the pressure gradient. So when I'm studying this, clearly you have, in terms of your thermal gradient right now, you have a La Nina signal, temporary, but still there. Okay. You don't see any indication of an El Nino signal growing down here. The water here, the cold water here is way too weak of an anomaly. When you're talking about only minus 0.5, that far below the sea surface, that's like a drop in the bucket. That's really not all that impressive. You certainly have some good warm water here. So this looks like, based on the data I'm seeing now, at least through spring, we'll transition towards a warm neutral state, but not really a robust El Nino signal, unless we start seeing more of what we're seeing here with our MJO. The MJO this spring is going to be the dominant feature. And typically, when you have a dominant feature of the MJO in the spring, that does increase your severe thunderstorm potential. Okay. In my opinion, you end up with a very volatile forecast. I if we continue to see uh, this type of signal showing up phase 1 and 8, let's go 7, 8, 1, 2. Let's say it stays right in here in the long range, which again, I never take this verbatim, but you kind of get the theme here. 7, 8, 1, and 2. So when you're in this area here, you tend to get pretty good periods of severe weather sparking up in the Southern Plains, the Mississippi River Valley, Tennessee River Valley, definitely the Southeast, but that's kind of par for the course. But the Mid-Atlantic can see some pretty good severe weather, especially once we get into April and May. Um, the reason why we wait till April and May around here in the Mid-Atlantic is that the sea surface temperatures off the coast here creates pretty good stable environment. So you got a chance for some thunderstorms, or not severe thunderstorms, over like eastern Pennsylvania, away from that marine influence. But the dominant influence of the marine influence around the Mid-Atlantic is what creates such a difficult time with forecasting for convective severe weather. So far, none of these signals would suggest any type of winter weather potential that one individual was talking about. Yes, in the winter, like in the dead of winter, January, February, deep February, or December, this signal here would certainly be supportive for winter storm potential. Not in the spring. In the spring is different. And the reason why you can't use the same rules is because the wavelength of the jet streams are changing. Why? Because our thermal gradient is relaxing. Why? Because the whole atmosphere is warming, because we get more direct sunlight. Yes, I know that pesky sun angle. It becomes more and more of an issue. And it leads to a moderation of your polar air masses, which changes the wavelength of your jet streams and changes the whole dynamics in terms of how the tropical forcing influences your jet stream pattern. So typically, I'm selecting March, April, May as kind of like an overall theme here. Typically, when we have phases 7, 8, 1, and 2, that's right here. 7, 1, and 2 are wet weather patterns for us. So 3 of the 4 potential phases are wet weather patterns for us. So I'm a little hesitant going well above, like some of the long range guidance is going. Let's shoot for normal first. And I say that because when you're dealing with convective weather, and you're overcoming a general dry environment, yeah, you kind of need to to just kind of hold back some of the expectations here. We're dealing with a very dry environment, especially over southern New Jersey, around the Delaware River Valley. And I'm concerned that while it's supportive for a active weather pattern, there might be a lot of frustration with thunderstorms dying out while approaching the Delaware River Valley and approaching the coastal plain because of that dry influence. Now, if we get a couple of storms that are just pure rainstorms, not even talking about convection, just steady rainfall all day, something like that in late March and in April, then you start to overcome that influence. So, what we need to do is really saturate the lower levels of the atmosphere and your boundary layer. Okay. Otherwise, if you just rely on convective weather, thunderstorms, then you're going to end up with a lot of disappointment. So, this signals above normal, aside from phase 8, which is basically your break, which is typical. But let's temper down the expectations to near normal and see if we can push to above normal if we can overcome the dry boundary layer that is in place due to our drought conditions. In terms of temperatures, this I think you'll like a lot more. 7, 8, 1, and 2. The influence of this from the MJO perspective is a little bit limited. Okay. It's not the same direct impact, but this does tell me that you're going to have a lot of progressive passive polar air masses. So I don't see a huge ridge with very warm above normal temperatures, but I also don't see any sustained cold, like a cold spring. What I'm seeing is a lot of waves of polar air masses and Pacific air masses fighting each other and then interacting with air masses coming out of the Gulf Coast. So, three air masses are going to be dominant features. Is there potential in this signal for backdoor cold fronts? You really don't want to use the MJO for forecasting backdoor cold fronts, but that's where we start to go to our next discussion, our polar vortex. Now, I've been seeing this image via the GFS, the European ensembles, even the AI guidance, all screaming about a split polar vortex. First of all, use a little bit of salt here, just a little bit. Now, understand where we're at during this time period. This is the middle of March. During the middle of March, yes, you can definitely get a split polar vortex. Why is that more likely, even in the strongest La Nina years? Well, the reason why is because our polar vortex overall is weakening. We're moving towards the warm season. So, with more direct sunlight, you warm the stratosphere more uniformly. You start to lose that support for a powerful thermal gradient in the stratosphere. You also start to lose the direct connection between the stratosphere and the troposphere. Remember, we're in the troposphere. The stratosphere is what we're looking at right here. The connection between the two is not as strong. But at the same time, what this tells me, we look at the whole evolution that, okay, March is going to start off with a bit of, because of this influence right here, a bit of a cold air mass, which we're all expecting on Sunday into Monday. Okay. Then we see very strong support for just Pacific dominated air masses. So that gets you through the middle of the month. Now we're up to this point here, towards the middle of the month, and we have this supposed split. Okay. The connection here, the signal here, does not scream to me sustained 30s, like some individuals are talking about. Instead, what this tells me is that you have a very powerful polar and Arctic air mass in Canada, in Quebec, northern Quebec. You don't really have high latitude blocking because this is displaced a little bit too far north. This also would suggest, if it's placed like this, your trough axis in the troposphere is going to be on the coastal plain. So this isn't exactly a stormy pattern either. This is one where your low pressure systems are more likely to be intensifying out here rather than out here. So, again, a couple of negative issues with that. This is a transient weather pattern. So, why is this even a threat? Why is this even on the table? Well, that's because our polar vortex is weakening. This is the zonal winds here, okay? So, this is where we normally are on average, and the forecast is basically to fall within that average. Now, notice the average is below zero here. What does that mean? Okay, so this is winds moving in a westerly direction at around 15 to 20 meters per second. Okay, now remember what we talked about with the QBO, right? Remember, we're going from westerly to easterly. Well, this is part of that process. The polar vortex is weakening, so you're seeing that in the model guidance, and you're seeing this signal here. What that tells you is that the polar vortex is collapsing. This happens every year. This is not something that's unusual or something historic or something that can create blockbuster events. It's just the nature of spring. And with the nature of spring, most likely right around when we have opening day in baseball, there will be some cool polar air masses. However, because we're going to be dealing in this time period with a positive NAO, Arctic oscillation, and EPO, and a negative PNA, what that all basically means is that it's a warm signal. It's a signal that draws in a lot of Pacific air into this weather pattern. So when we take a look at this, this is the European 46-day forecast here, and this really covers March through about middle of April here. Yeah. So about April 11th or so. And again, the way you use this model guides, you don't use it verbatim, okay? You just kind of get the themes. And so let's just scroll through and take a look at these themes here. Um, and as always, I will be answering all your questions once I get done with my spiel. So everyone in the live chat, you're first, and then anyone on social media land, YouTube, and so on and so forth, you're next. If you have a paid question on YouTube, you're first of the social media. So I just want to make that clear. So in this evolution here, it tells me that your polar vortex influence is displaced northward because your influence here is focused more towards Asia than North America in terms of the interaction in the troposphere. Again, this is stratosphere, but we have more influence in the troposphere. It's not the same type of influence that you would see in January and February. At this point, we're in the middle of March. Different game, different wavelengths, different type of games, different type of rules. Okay. So looking at this, yeah, I like the idea of just a roller coaster of March, which is typical. Looks like March is going to come in like a lamb. Will it go out like a lion? Possible. But one thing I can say is that it is not a cold weather pattern. And the reason why we know that, let's look at the middle of the month of March. Look at this. This is zonal. This isn't a storm pattern. This isn't even a high latitude blocking support for any type of sustained cold weather. This is a type of pattern with a lot of Pacific air masses marching across. Watch out for a good severe weather outbreak really setting up in the middle of March. And then as we move towards April, you have that signal. You don't see any large ridges or troughs. Very progressive pattern. We're not seeing a strong tropical signal. Why? Because it's all muted. It's all over the place. So I suspect we'll have a very active subtropical jet stream. So we'll have a lot of short waves getting really amplified in Texas, marching across into the Mississippi River Valley with a lot of severe weather outbreaks. And then those will interact with faster polar short waves that will just be clipping the region. And that's where we could get our potential severe weather. With that being said, I would not be surprised in this scenario, especially as we get towards April and May, where you get a severe weather outbreak in the southern mid-Atlantic, severe weather outbreak in New England because of the two short waves coming across, right? Moving from west to east. but we get caught in the subsidence and miss out. I would not be surprised if we see that quite a bit in the spring and summer. I'm just putting that out there because I can just visually see it with the way that this pattern is set up, with the separation between the subtropical and polar jet streams and the activity in the subtropical jet stream. When you have two robust short waves marching across, moving west to east at about the same clip, someone is going to miss out. Someone's going to be dealing with subsidence and sinking air between those two short waves. So I'm just going to put that out there as something that could be a unfortunate theme. And then once we go beyond that point, looking at the really extended long range guidance for April and May, you're not seeing a strong signal of a powerful southeast ridge anymore. I think by this point we lose any type of cold neutral environment in the ENSO state, and we shift more towards that warm neutral state that I'm thinking we're starting to see develop. And by this point, you start to open up the potential here for short waves to undercut this ridge, polar short waves diving in, and you get the signal here setting up for, again, a very active severe weather season over the eastern two-thirds of the United States. And then you just see exactly how this evolves. In terms of any backdoor cold front signals, I'd keep an eye on this feature right here. When you have an upper level low right around here, sometimes you can start getting these backdoor cold fronts. Now, what that basically means is that you basically have cold fronts dropping in from the Gulf of Maine and marching their way through Boston, New York City, and stalling out somewhere between Philadelphia and New York City. Sometimes they move through Philadelphia, but it's rare. They could create a lot of havoc in terms of cloudy skies and temperatures stuck in the 40s, while just to your southwest in southern New Jersey and Philadelphia, you're in the 70s. So it creates a lot of havoc with temperature forecasts. Sometimes you get a pretty good rainfall event, but normally it's just cloudy and foggy and drizzle and just kind of raw and disgusting out. So we'll have to watch out for that in April and May. And I think we lose that signal as we head into the summer. Now, in terms of summer influences, we still have to wait a bit to see how this ENSO event evolves. I really don't like the idea of any type of robust El Nino developing here. Weak, very weak El Nino, I kind of like that better right now based on the data I'm seeing. And that could be a real influence as we move into the summer with a robust subtropical jet stream. So, the way I see spring taking shape here is one that I think is going to be active. It's going to feature some pretty impressive severe weather events. First half of spring is likely to feature a lot of volatile temperatures. Stay away from any sustained Arctic blast ideas. We will definitely get, especially the start of March. We already have that built into the forecast of a blast of cold air that gives you one or two cold mornings. It's going to create havoc with the growing season initially. So I always say around the mid Atlantic, protect your if you're planning on planting and you're doing anything in March. Typically a lot of people wait till April, but protect a lot of your seedlings because they're going to be dealing with a roller coaster of like one day in the 50s, the next day in the 30s, then we go back into the 60s, which is perfect for getting everyone sick too, because you never know what to wear from day to day. And then I think after that, after once we get towards late March, April, and May, then I think we see more of a sustained influence from the Pacific, less from the polar regions, and you end up with temperatures slightly above normal, especially in your urban areas. Precipitation, if we get a pretty good rainfall event in late March to really saturate the boundary layer, then I think we see a more robust severe weather season. If we don't see that and we have this continuation of these drought conditions, then you have to overcome a dry boundary layer. So let's say this is the ground, right? This is the soil, right? Your boundary layer is up to about here, let's say about 10 meters. Now, you might be thinking to yourself, Stephen, who cares about 10 meters? Well, thunderstorms do. If you have a dry environment at 10 meters, right, then when thunderstorms come through, Low level moisture is like high octane fuel for thunderstorms. And if it's lacking moisture, it's lacking fuel, and therefore they weaken, wither, and die. Okay. That's why it's really important, because if that continually happens, then that dry environment just feeds back on itself. But if we can get a couple of, we don't need like a 2 or 3 inch rainfall, just like a half an inch here, an inch here, another inch and a half there, they start to add up. It saturates the groundwater, ground table, the water table. It saturates the lower boundary layer, and then you open yourself up more for convective development once you head towards late spring and then of course into the summer months. In terms of anything going on right now, I mean, it's pretty quiet. It's quiet out there, which is nice. We have some showers that are approaching the region. Temperatures, of course, are well above freezing. This is associated with an initial warm front. We do have some moderate bursts of rainfall moving through east central Pennsylvania. Those will continue to head towards our neck of the woods as we move on through the evening hours. So we'll get a little bit of rain, maybe about a tenth to at most a quarter of an inch of rainfall moving through. And then this cold front back here is what's going to be marching through tomorrow, producing more scattered showers. Again, nothing really heavy, but again, any rain that we can get, I'll take. Let me refresh this here real fast, and you can see very progressive pattern. Okay, very progressive, very fast moving. There's no sign here of any type of blocking. And by the way, when you see this signal over the Pacific, you should take any type of sustained cold signal with a huge grain of salt. Polar vortex or no polar vortex. This signal right here, heading right towards the west coast, is bad news for any type of cold weather forecast, whether that's in the dead of winter or in the spring or any other time of year. So, again, observations are always king. It would be helpful if I actually show it. There we go. So let me go back here again. There's our showers. There's our rainfall coming in from the west. Cold front back here is what's going to be moving through. There's our infrared satellite. Again, notice everything moving west to east. And then what I was talking about with our upper level winds. This is a 250 millibars, very progressive jet stream. Anyone that's running around saying cold is I don't know. I don't get it. I've gotten that question about 16 emails. Hey, someone's saying that there could be a blockbuster winter storm in April or May or March or sometime. It'll happen. I'm like, okay. I'll answer. I'll cover it in a live chat just so we can put it to bed. Over the next 90 hours, series of short waves, very fast moving, very progressive. Sunday is going to just be shockingly cold and unfortunate. We do have potential here for some good rainfall for tomorrow. Again, 10th, maybe a quarter of an inch of rain in a few spots here. For the weekend, not really seeing a lot of rainfall. Saturday, you'll get a few isolated showers, but notice the precipitable water values are nothing like what we're having for tomorrow. So generally, when you're below 0.6 inches in precipitable water value, you're going to be under a tenth of an inch in terms of rainfall during this time of year. Again, because it's warmer. And then for Sunday, it will certainly be dry. It is very dry on Sunday, but it's also going to be very cold. Okay. Now, when you have 850 millibar temperatures like this, what you want to remember is that the sun angle really warms you up, right? It's important. So when you see this, it's not temperatures in the 20s like it would be if this was in early February or January. This instead is more like mid 30s, lower 40s. Usually the mild guidance is a little bit too cold, so I always warm it up about a degree or two. But even then, sometimes I'm too cold in that approach, and you get surprisingly much warmer than what's being forecast in the guidance. And a lot of that has to do with trying to figure out the influence of the sun angle combined with the urban heat island effect. Again, now we have more sidewalks, more pavement, more houses. So your warm up can be that much faster. And as that cold air comes in, it leaves just as quickly on Monday. And by Tuesday, we are well above freezing. with plenty of warm air and temperatures pushing back into the 50s and 60s. So, again, no major rainfall events here. But I do want to just, because I know a couple people are asking about it, this time period right here, 246 hours. You have an area of low pressure off the coast. Again, I wouldn't take any of this verbatim, but a lot of people are saying, like, hey, this is going to produce accumulating snow, maybe an inch or two or 4 inches. But when you look at this time period, the key rule is this: you want to be over below -6 degrees Celsius in your 850 millibar temperatures for snow accumulation after basically March 5th, right? So that way it negates your sun angle impact. And then you want to have a snowfall rate over 1 inch per hour, which we don't have in this intensity. So what this really is what I like to call white rain, where basically you might get some snowflakes in the air, but nothing actually accumulates. So your snowfall map doesn't work out very well. You don't want to use snowfall maps this year. Don't even, this goes beyond just this year, but any year. Once you get into March, what you really want to use is snow depth, because if you're not going to do the work and look at the analysis and all that stuff, throw away the snowfall map and focus on snow depth. But even then, that can be deceptive. So you have to take into account when you see this, what are the boundary layer temperatures? What time of day is this? If this was happening at the middle of midnight, I might be a little bit more forgiving in the idea of thinking that this is going to be an accumulating snowfall event. What this is, though, in the middle of the day, literally at high noon, is rain. Temperatures in the upper 30s, rain. So that's why, as a meteorologist, you look at this and you make those adjustments, whereas your phone app or whatever you might be using that's just digitalized without the help of a meteorologist will tell you, hey, look, we have 2 inches of snow in 10 days, but in reality is nothing like that at all. So with that, it is time to take the questions and see what we have out there. So, of course, we're going to start in our live chat here. As always, Card is up and running, asking plenty of questions, but everyone else, more than happy to ask any questions that you like. I wish those posting snow maps from 10 to 15 days out in March would look at the SPC website and see the below zero 850 millibar temperatures, while surface temperatures are in the 40s and lower 50s. Sun angle matters. Yeah, he's right. Just look at how quickly the cold air is shrinking in the northern hemisphere. Yeah, this model error, no matter what model you're using, European AI, look, they all have limitations, which is why you must compare observations first. And with that, they're a little bit too robust with their cold air right now. Okay, so you kind of want to step back a little bit. Just one step back. Just hold it back a little bit. There was no real La Nina. That is true. It did not meet the criteria. You would think so, but we'll see what happens. If we get an El Nino this summer, any ideas yet on the strength and orientation? No idea on the orientation. Strength, I'd be very suspicious of anything moderate or strong right now. I don't have any data suggesting anything like that. Maybe a weak El Nino, but we have some time to keep an eye on it, watch the evolution, see how it plays out. Next Wednesday is Ash Wednesday, already time flying. That reminds me, next week we're going to have the live chat on Tuesday because we're going to be out on Wednesday. So live chat next week on Tuesday. Okay, so just putting that out there. Any early summer thoughts yet, or is it still too early? Well, I gave a few, but I'm not seeing a strong tropical forcing signal yet. And that tells me we're going to get a hodgepodge of a lot of different weather patterns this summer. Um, I don't like the idea of a sustained heat wave in this pattern, especially if we get more of an El Nino look to it, because then the polar jet stream is a little bit more aggressive in the summer, and you also have stronger subtropical jet stream influences. So we're gonna have to wait and see how that plays out. But right now I don't see like a huge ridge or anything of that nature, or Bermuda High. But again, we're gonna have to just keep an open book on that, and we'll see how that plays out. With the cold water off the coast, do you anticipate sea breeze fronts kicking up storms this spring into summer? Mm, if we overcome that boundary layer issue with the dry air, then yeah, sea breeze fronts can create more potential for some impressive thunderstorms. But a lot of that is based off of the boundary layer moisture gradient being neutral. So the low level air coming in from the cooler low level air might actually have more moisture than the warm air that is over, let's say, central New Jersey. So with the interaction of the sea breeze front, you might actually get more of a stabilizing signal where you just get a lot of low clouds rather than actual severe weather. But if we overcome that cap, then there's that possibility. And I see we have a lot of activity on YouTube. Look at that. When are we going to get March snowstorms? We're not. We're not. I don't know who's running around calling for March snowstorms. We're not getting March snowstorms. Uh, let's see here. What caused us to get 4 nor'easters in March 2018 and even a snowstorm on the East Coast during the beginning of April? So, what happened during that time period, the polar vortex did not drop towards eastern Canada, but rather central Canada. And what that led to is more of a continental influence in your polar and Arctic air masses to remain sustained. Now, during that time of year, the snowpack over there during that time period in central and eastern Canada was far more robust. So your polar and Arctic air masses were more impressive. Combine that with us in an El Nino state, although weakening, that led to an active subtropical jet stream that interacted with some of those polar air masses that increased the potential for snow development. During that year, it was a unique year. I remember it very vividly because it was a pain in the ass to forecast for. But even in those time periods, you'd get most of your snowfall accumulation in the early morning hours, and by the afternoon, even with the snow, everything will be melted because of the sun angle. In April, your influences were more focused for higher elevations, not the coastal plain. You'd get maybe some dusting on the grass, but then everything else would just melt very, very quickly. Let's see here. Let's see. How did we end up seeing a colder than normal winter for eastern U.S. despite a lack of high latitude blocking? You don't need a lot of cold air you don't need high latitude blocking to support waves of cold air. You need high latitude blocking for winter storms, not cold air. So you can, with the stretch polar vortex and the way that things evolved, we certainly got some very impressive cold air masses in January and February and even December, which was well forecasted. I'm really happy with the winter forecast this year. It actually worked out very, very well. From everything from the below normal snowfall idea over the coastal plain, near normal over the interior, which when I say the interior, I mean the Poconos, Catskills, Lehigh Valley. It was kind of like a mixed bag. As you moved more towards the Delaware River Valley, you were more below normal. But as you moved towards the Poconos, you were more near normal. But overall, I was pretty happy with the way that the forecast evolved. And again, I forecasted no blockbuster major winter storms, which is why in the spring, I'm even less likely to support any blockbuster winter. There's no blocking. No blocking. Whoever's running around saying this nonsense, there is no blocking. You're not going to get a storm. Period. Done. The live made me very excited for spring. Awesome. Hey, look, As we move into the spring, we're going to definitely do one on books because we got that request. I do remember that. Susan actually reminded me about it as well. So we're definitely going to be hitting that up. We're going to be talking about my journey into earning the certified consulting meteorologist. We'll talk about what that is in case anyone has any questions on it. And of course, I'm going to continue to also prop up the digital meteorologist seal, which is very important. I suggest anyone that is doing what I'm doing to definitely go for it. Um, let's see here. Can Long Island see severe weather? Okay. So, on the 4th, 5th, first of all, 4th, 5th, or 6th of March is not even reasonable. Okay. And for anywhere. Okay. So I'm just going to put that out there. Um, in the forecast, there's no indication of that. Maybe in eastern Pennsylvania. But why is Long Island even more difficult? Because your water around Long Island is very stable. Okay. It's cold water. So cold water stabilizes the atmosphere, limiting your thunderstorm development. And that's true all the way into June. Once you get into July and August, you start to reduce that. All right. And that's where you can get some impressive severe weather. But the stabilizing influence of the Atlantic Ocean really hampers severe weather on Long Island. Let's see. I think I already answered that. Let's see. The difference between a positive, neutral, and weak Nino versus a strong Nino is the intensity of the thermal gradient that we were discussing, thus, the difference in the pressure gradient and wind gradient. When you have a strong El Nino, you have a very powerful, overwhelming subtropical jet stream, which leads to a very zonal pattern with a lot of Pacific air surging across the United States. When you have a weak El Nino, the polar jet stream is able to come in and play. Okay, they start to play nice, and that's where you start to introduce more robust storms with more interaction overall. When are you going to review? When are you going to review the winter? Well, I already started doing that. I did a review in the premium dashboard. Um, Honestly, I mean, if you have any questions, I'm very happy with it. It verified to within 99%. I said that it was going to be below normal on the coastal plain, and it was. But we certainly had plenty of activity. We had a lot of mixed uh, winter weather events as we got through February. Ice events. We had our cold air. The stretch polar vortex warning worked out very nicely. I'm I'm personally very happy with and the reason why I'm really happy about it is that the 2 years before that I did struggle trying to pick up the signals because I was having a difficult time trying to figure out how the influences from Tonga was screwing with the stratosphere. And I finally got that nailed down this year. And once I got that nailed down, then the rest of the forecast worked out pretty nicely. So, sometimes you have 2 bad years and then you bounce back and you get a good one. So this is definitely a good one. Let me go back here. Let's see. How do you think the weekend of March 17th is going to look for the area? March 17th, that's pretty far out. I really don't have any real trustworthy data that far out. So follow back with Christopher, follow back with me in about a week, and then we can have a little bit more data. Right now, I have literally no data, no reliable data to give a reliable description of what to expect that far out. Do we have any questions on X or uh-oh? My wife has that look saying, "Oh, geez, you're gonna love this." Oh, let's see what we got here. What do we got? Uh, there will be discussions. What? What are your thoughts? This is from Elizabeth. I'm not going to butcher the last name. Yeah, yeah, I'm bad at them, so let's not go there. What are your thoughts about severe weather setups that are trending for the next couple of weeks? Severe weather typically around the mid Atlantic. I'm usually focused more towards eastern Pennsylvania, somewhat western New Jersey. Why is that? The Atlantic Ocean. The Atlantic Ocean is an incredibly strong stabilizing factor, especially during the early spring. Can you get a strong thunderstorm to get all the way down towards the coastal plain? Yeah, you could pull it off, but I wouldn't forecast it. It would be more of a very rare event. Most of those storms are going to die. So most of the region really you miss out. So if you're looking for severe weather for whatever reason, maybe you're storm chasing, um, you really want to focus on eastern Pennsylvania. That's where you want to be. One thing that's going to be very interesting in the spring is um, the urban heat island effect around Philadelphia has really helped to enhance the potential for tornadoes, weak tornadoes. It is my theory that the stronger urban heat island effect causes more low level circulation because of the differences in temperatures. And then you add in the thunderstorm complexes, and then you end up with more F zeros, maybe even F1 setup. I think the more that we build around the I-95 corridor, the more we're going to see that, because you're going to see this this warm thermal gradient on the I-95 corridor and the Philadelphia metro. But then in your suburbs, let's say in central Monmouth County, central Ocean County, and then towards Berks in Pennsylvania, you have cooler environments. So that gradient leads to low level circulation. And thunderstorms develop tornadoes when you have a low level circulation and also a strong updraft. So beforehand, we didn't really have that strong low level circulation because our urban heat island effect wasn't as strong. So you would just have pretty strong updrafts and downdrafts and a lot of hail and so on, but not a lot of tornadoes. That was kind of like a rare thing. Okay. It was still possible, but it was rare. I mean, you've had tornadoes even in New York City back in the 1800s. So it's not impossible, but we're seeing it more for two reasons. One, our technology could see it better, especially with radar. And two, the urban heat island effect is leading to more low level circulations. And when you get these thunderstorms with strong updrafts, there is your tornado signal. Favorite phase for the summer? Stable marine air mass for the wind. Absolutely. Certainly makes my forecasting easier. Let's see here. Uh, was the Tunga volcano one of the reasons why the last two winters were so mild? I mean, it was part of it, but the ENSO events were pretty much the driving cause for that. Let's see. Do we have any other questions out there? Oh, guess we do. What do we got here? You often talk about regions, coastal, northern, interior. It'd be nice to add a map to the premium that outlines these regions. Yeah, I was thinking of maybe doing that, just to kind of get a general idea. I kind of see, my thing is that sometimes I make these assumptions that everyone knows what the heck I'm talking about because I've been doing this for like, I don't know, 30 years, right? 20 years professionally, and then 10 years before that. So when I say coastal plain, I'm just assuming that everyone knows what that is. But heck, I mean, there's some people, not saying you, but there are some people that don't even know what town they live in. Yeah. They're like, where am I on the map? I'm like, don't you know where you live? But I found that that's not always the case. It's like one guy thought that New York City was all the way on the east end of Long Island. I'm like, no, no, what are you doing? Well, I could see the water. I'm like, okay, you're on an island, dude. There's water all around you. But I digress. That was an interesting conversation. But I could definitely look into it and definitely create one. I mean, it's not that difficult. It's just now that it's spring, I'll have a little bit more time, so I'll look into setting that up. It shouldn't be too difficult to knock that out. Usually, what I try to do is go by the valleys and some of the really known forecast areas. So coastal plain is usually south and east of the I-95 corridor. I-95 corridor, you know what that is. That's basically Philadelphia, New York City, right? Now, the reason why you can use the I-95 corridor is that, and let me see here. In fact, let me pull up a map here. See if I can get one that's a little bit. 1 second. I'm going to. Let's see. Okay. All right. So. Okay. So we will change the base map. Excuse me. There we go. Perfect. Okay. So usually the coastal plain is down here, right? I mean, you could see it, much flatter ground, much more direct influence with the Atlantic Ocean. Now, why do I use the I-95 corridor? Well, the way that they built the I-95 corridor was very important because of the way that we have our topography. Now, what we have here is the Hudson Highlands here coming off of the Appalachians back here. So you have true coastal plain here. You have hilly mountainous areas here. And in between, that is where we have the I-95 corridor because it's very easy to build the roadways there. So you have that connection here, and you can even see that influence with the way the thunderstorms coming off through northern New Jersey. They weaken sometimes because they're coming off of the higher elevations. Now your interior is usually north and west of the I-95 corridor. If I need to get more specific, I might use the Lehigh Valley, the Poconos, Catskills, Hudson River Valley, all of northern New Jersey, and I'd say northwestern Connecticut is what you call the Hudson Highlands. That's like your mountain. That's your not even mountains, but more like hilly areas and some lower mountains. That's all up here. And then of course your coastal plain would be like Long Island, coastal Connecticut, New York City, central and southern New Jersey coast. So that kind of gives you the idea. And that's usually how I set it up. So interior is pretty much as a ballpark rule, north and west of I-95, coast, south and east of I-95, and then you got I-95. Also, I say a lot the Delaware River Valley, which really encompasses, well, the Delaware River and its valley. So again, you can get close to the I-95 corridor. Normally, what I'm trying to focus on is this area right here. Why? Because especially in the summer, a lot of your hot weather, your hot and humid air masses comes in from this area right here. The warm air surges up against the Appalachian Mountains right here, and then basically gets funneled right into here, right? So right here is your Delaware River Valley. So what happens is typically you'll get temperatures spiking to around 100 here. It could bleed into basically right around Newark. So you get this wedge here of very hot air, but then it gets sandwiched in between the more stable, cooler influences from the Atlantic on the coastal plain and just the higher elevations here, blocking the warmest air over the Poconos and Catskills. So you get this tongue of warm air right here, which also lines up very nicely to when you're forecasting severe thunderstorms because you get your greatest instability right in here. And then you get your cold front coming through, interacting with that instability. And this is generally where I'm looking for an enhancement of tornadoes. Right around, let's say, King Prussia, Reading, Lancaster, Westchester, King of Prussia, all those areas is where I start to look for that. And then around central New Jersey and down in this area here. Okay, because then you get your thermal gradient with your cooler waters right here. Then you get this is your optimal zone right here between the two. And then this warm pocket here is where you get your thunderstorms intensify, weaken for a bit, and then intensify again, and then run into the stable air. So that's usually how I play it out. I think that's a pretty good breakdown. I'll take a look and see whether I can make a map or something of that nature. Let's see here. That in the last 2 winters had a polar vortex camped over Europe and Asia. That's definitely true. Based on your March forecast, it seems your first half of March is slightly below normal. Yes, it is. And the second half above normal. Yes, because we're going to get more Pacific air masses involved by then. Averaging normal temperatures for March. Yeah, that's pretty much where I'm looking at here. I'm not seeing any extremes one way or the other here because everything's just moving very quickly west to east. I would say that in northern New Jersey, north of exit 11, on the Turnpike, the Garden State Parkway is a better divider than I 95, as east of Garden State Parkway from Middlesex to southern Bergen is fairly urbanized. I get what you mean, but it's hard for me to make that connection for Pennsylvania and for Connecticut to make that that setup. But I get what you mean. Absolutely. No extremes from now to next fall works fine for me. Well, we'll see how that works out. And we'll take one more social media question. Do we have anything over there? This is the last one. Oh, okay. Thank you. Unfortunately, I never reached my dream of becoming a meteorologist, but I still stayed passionate. Hey, a lot of people's absolutely. I mean, I still say keep an eye on it. You never know. Life's too short to not do what you want to do. So if you want to still keep going for meteorology, I would strongly suggest you do. But thank you for following. Let's see here. And Eddie, any snow left in the Hudson River Valley, Poughkeepsie area? Nothing significant. I know that you're going to get plenty of people running around with snow maps. Don't waste your time. Don't waste your time. I'm telling you right now, don't waste your time. Okay. Anyone that's telling you winter storms for the rest of spring are not looking at the teleconnections. All right, let me put it to you this way. When your North Atlantic Oscillation, the NAO, is raging positive and your PNA is raging negative, anyone telling you winter storms is a raging idiot. Okay? They don't know what they're talking about. So I'm just going to put that out. What universities offer meteorology programs near New York City? I mean, there's just off the top of my head, Rutgers. There's a lot of SUNY schools that are really, really good. SUNY Albany is amazing. Um, I know it's a little bit further away from New York, but there's a lot of people that come to SUNY Oswego, where I went to college. Now we're from Long Island, so like a ton. So it's not that far away. It's maybe a hour and a half train ride. So it's not too bad at all. And only like about a 30-minute plane flight. Driving was fun. That took about 6 hours, but that wasn't too bad. Really, the 6 hours is more due to us stopping to have lunch, me and my dad. Um, but yeah, absolutely. But I would definitely take a look at your SUNY schools. Like I said, Albany is a great option. Oswego is a great option. Rutgers is a great option. You know, so and yeah, I'm not telling you where I live. No, thank you. I've already had one stalker. I don't need more. So yeah, let's see here. Let's see. Oh, integrated calculus was beyond me. Yeah, that was difficult. Let me tell you, the thing with calculus is that um, it's not just being able to do the math. You have to visually see it, and it takes special individuals. Like my niece, I think is going to do really good with calculus, because she is amazingly smart. She's young, but she has that same trait that I have, where you can visually see things, see theories, and I think she's going to be outstanding. Differential calculus I can handle. Integrated calculus, integral calculus, I was totally lost. It's tough. It's a challenge. Well, it is 9 o'clock. I was surprised we got as far as we did. That is outstanding, and I'm honestly very, very impressed of the number of people that joined in the live chat this evening, considering we don't have a lot to talk about in terms of active weather. But I really do appreciate it. I thank you for joining. And I will see you next week again on Tuesday, not Wednesday, Tuesday at 8 p.m. So I'll see you there. And in the meantime, stay safe out there.